Good day once again. My name is Graphics. Today we'll be looking at bending moment. Bending moment. Bending moment. Now, let's assume we have a beam. A beam having a reaction at point A called RAY and a reaction at point B which is RBY. Now let's assume there's a weight on it, a load which is called the weight. Now let's assume the beam has carried so much load that instead of the load to break the beam, the load tends to what? To bend the beam. Right? The load tends to what? To bend the beam. So the force that bends the beam is said to be what? The bending force, which is the bending moment. Right? So we say that the bending moment is the algebraic moment, the algebraic sum of all moment of forces, the algebraic sum of all the moment of forces acting either to the left hand side or to the right hand side of the section of the beam. Right? So from here, let's now assume that there's some point and you need to know when you're dealing with bending moment. If I have a beam that has bent towards this direction, right, this is the beam bending towards the direction, and if I at the ending the reaction also will bend inward, and the reaction also here will bend inward here. So if I section this part, this will be my right hand side and this will be my left hand side. Right? Now when the beam is clockwise, is anti-clockwise at the right hand side, or it is clockwise at the left hand side, you say that what? The bending moment is positive. That is point A. But for point B, let's assume it is bending downward in this direction and we are sectioning it. So this is the right hand side, and this is the left hand side. Right? So if reaction is going inward and it is going inward here, right? So in this case here, when the bending moment is the clockwise at the right hand side and anti-clockwise at the left hand side, you see such a beam is what? Is sagging. Right? So in this case also, when the beam is clockwise at the right hand side and anti-clockwise at the left hand side, you say the bending moment here is negative, and such a beam is said to be what? Hugging. Is that taken? Now we will take an illustration of this beam using our previous example where we calculated our beam. Now let's take this illustration. Here we have this example where we'll be looking at the bending moment of this beam. In our earlier video, we calculated the shear force of this same diagram, this same figure. Now we want to calculate the bending moment. So calculating for the bending moment. At this point here, we will take moment about A. Taking bending moment about A. So here we want to calculate for bending moment. Calculating for the bending moment. So we are here. This is point A, this is point B, this is C, this is D, and this is what? E. So at B, so we are going to write bending moment at point B, and that will give us, let's see, if I take moment at B, there are no distances here, so bending moment at B is what? Is 0. So it's 0. Bending moment at B is 0. Then the next one is bending moment at E. So you're going to write it out that the bending moment at point E equals to, now let's see, if I take moment about this force will be going this direction, right? So if I now put as if the beam is bending like this, so if you look at this diagram here, it is going like this, that is clockwise at the what? At the right hand side, which is what we're having here, right? And that is sagging, so bending moment is positive, so we'll be having 4 times 1. I'm going to be having my 4 times 1, so our answer will be 4 kilonewton meter. Now the next one is bending moment at D. So the bending moment at point D will be equals to, now at point D, this force here will be going this direction, and if I place my beam bending this way, right, and when it's going this way is at this figure here, so that's what? Negative. So we'll be having it to be 2, and this one will go in this direction too, so this is negative and this is what? Positive. So it will be 2 times distance from here to where I take bending moment, so 2 times 1 minus 2 times 1, we'll be having minus 2 times 1 plus the next one will be this, and it's positive, that's how it will be 4 times distance between these two forces, and that distance is what? Is 2. So 4 times 2, so we'll be having 4 times 2. So in this case, this will now give us minus 2 plus what? Plus 8, and that will be 6 kilonewton meter. Now the next one will be bending moment at C. So the bending moment at C, bending moment at point C will be giving me, now the same thing will be applied here. this guy will be going this direction also, and if I place my beam this way, it's something like this that we have going this direction, and it is what? Negative. So this one is also what? Negative. So what I will do is, it will be 4 times distance between this force and where I take moment from. So 4 times minus 4 times 1, we have minus 4 times 1, minus 4 times 1, plus the next one will be minus 2 times distance from here to here, which is 2. So we have minus 2 times 2, minus 2 times 2, plus distance of this one, this is plus now, so it will be 4 times 1, 2, 3. That is distance from this point. So 4 times 3, so we have 4 times 3, so this will now give us minus 4, minus 4, minus 4, because minus 2 times 2 is minus 4, then plus 12, and my value will now give me minus 4 is minus 8, minus 8 plus 12 is 4. We have 4 kilonewton meter. Now the next one that we have in here will be bending moment at what? At A. So if you take bending moment at A, so this will also be coming this direction, will be coming this direction also, and it will go in this way. If you look at it, that is hugging, and that will be negative. So we are have bending moment at A, bending moment at point A will now give me, this is negative because it is hugging, right? So minus 2 times 1, let's see, we have minus 2 times 1, plus the next one will be minus 4 times distance from here to A, that is 2, minus 4 times 2, plus the next one will be minus 2 times 1, 2, 3, that is 3, distance is 3, we have minus 2 times 3, minus 2 times 3, plus that will be plus 4, because this is sagging, plus 4 times distance of this, and that is 1, 2, 3, 4, that is 4 from A. So 4 times 4, so we have 4, we have 4 times 4, right? So this will now give me minus 2, I'll give you minus 2, plus 2 times minus 4 is minus 8, minus 8, 2 times minus 2 times 3 times minus 2 give you minus 6, 4 times 4 will give you 16, and this will now give me minus 2 minus 8 is minus 10, minus 10 minus 6 is minus 16, minus 16 plus 6 will give you what? 0 kilonewton. So the moment at point A is what? 0. It's easier if I look at the left also of A is 0, so any of that. So we have successfully calculated our bending moment. Now it's for us to draw our shear force, our bending moment diagram. Now still in the same diagram that we use here, we say that the bending moment at point 0 is this. So let's focus on the same diagram. If you look now, you go to the same diagram just below the shear force diagram. You are going to draw a straight line from here to this point, right? So that point will be 0, 0. So say bending moment at A at point B is what? Bending moment at point B is 0. So that means at this point here the bending moment is what? 0. Then the bending moment at E is what? 4 kilonewton. And this is point E here, right? So bending moment at point E is 4 kilonewton. So we are going to mark 4 up. Let me say 4 is somewhere around here, right? So in this case now, since the shape of the diagram is straight, then bending moment diagram will be what? Inclined in this direction. So that will be 4 kilonewton, right? So bending moment at D is 6 kilonewton. So I'll go to point D, which is this. It is 6 kilonewton. So from here I will assume my 6 is somewhere around here, right? So I'm going to still take it to that point, 6 kilonewton. From here to here is the 6, also inclined, right? So we'll call it the 6 kilonewton here. Now the next one is at point C. At point C it is also what? 4 kilonewton also, right? So I'll go to point C. This is point C here, and it's 4 kilonewton somewhere around here also, right? Which is 4 kilonewton. And I'm going to join this to this. So from here to this point, so that will be 4 kilonewton. Then bending moment at A. Bending moment at A bar is also what? It's 0. So I'm going to take it back to 0, which is at this point here. So I'll take it back to 0, which is here. So I'll join it together at this point. So this is the positive one here. So this is my bending moment diagram for that figure that we just seen here. So thank you for watching. We'll see you in our next video. Don't forget to click on the subscribe button and share. God bless you.